Okay, so these are the solutions to test 3, version 1. Let's jump into it. Number 1, convert the following ratios to have the same units on both sides and simplify the ratio to its lowest terms. Now, as a few of you pointed out, the units don't actually matter here. Technically, they're not supposed to have units. I made you include the units because units are important, and it's something that's expected of this course is for you to learn to constantly use units. So even though, yes, some of you are absolutely right, when you look at a ratio, typically you don't bother including the units. There's more to unpack there as to the reasons why. We're not getting into it. The reason I made you do it and the reason I'm going to do it is, again, just because it's good practice to deal with plenty of units all the time. So that's why. Anyway, let's jump into this. So I'm going to okay, sweet. Number 1, convert the following ratios to have the same units on both sides and simplify the ratio to its lowest terms. First one here, $15 to 75 cents. I don't know why, I always like converting from big units to little units and then reducing the fraction later. So I'm going to convert $15 to 1,500 cents to 75 cents. There we go. Great. And if I divide both of these by 75, just to see if 1,500 is divisible by 75, then I actually end up getting 20 cents to 1 cent, which is the answer I'm looking for. Great. In this case, because I've done the math already in my head, I'm going to go the other way, small unit to big unit. So I'm going to convert minutes into hours first. I know there are 60 minutes in 3 hours. So if I take 60 plus 60 plus 60, that equals 180. So here I have 1, 2, 3 hours. So I'm going to have 3 hours to 3 hours, which is a 1-to-1 ratio here. Great. Number 2, determine the ratio of the speed of gear A to the speed of gear B. So we are going from A to B. If gear A turns at 91 RPM and gear B turns at 13 RPM. So I'm going to actually first rewrite this B, because this B kind of looked like the 13 down there. I guess it still does, but oh well. I fixed it a little bit. Again, same thing I'm going to do is first thing I'm going to do is I'm going to try dividing both of these by 13. See if 91 is divisible by 13. If so, that'll make our lives easier. And lo and behold, it does. It is 7 exactly. So that leaves us with a 7-to-1 ratio. Great. That's gonna bug me if I don't fix that. Good enough. Okay. Solve the following proportions for the unknown variable. Okay, great. So on the left-hand side here, 0.6 over 48 equals 0.2 over x. Many of you solved this different ways. Something we can do, a little bit of a trick, we can swap places with the x and the 0.6. So we have x over 48 equals 0.2 over 0.6. Great. And now we can take the 48 and we can multiply it up to the 0.2. If we don't want to swap their places, we just multiply them. So we get 0.2 times 48 over 0.6. X equals 16. Great. This one, a little bit trickier. When we talked about this in class, the single colon means a ratio. So this is 20 over 32 and x over 96. The double colon means equals, that this is a proportion, that these two ratios are proportional. So that is how you set this one up to make it look more like problems we have done in class. This one, a little bit simpler. Our x is in the top, so less work to do. We just need to move the 98 over, and instead of swapping it with the 20, we are just going to multiply them. So x equals 20 times 96 over 32. Punch that in the calculator. You should get x equals 60 as your answer. Those were the first three. Question 4. A pump discharges 9 gallons per minute, can fill a tank in 2 hours. How long will it take to fill the same tank if you use a pump discharging at 12 gallons per minute? Now, I'm going to jump back to the book here, and specifically at the bottom of page 5, this little paragraph, this bottom one. So when establishing the ratios, you should set up the equations with similar units in each ratio and place small numbers in the numerator and large numbers in the denominator. Or you may place large numbers in the numerator and small numbers in the denominator. However, you must ensure that you place them the same way every time. So you're either doing small numbers on top or large numbers on top. One or the other, can't mix it up. So how do you know what to do? Where to put stuff? Well, basically, you take what you do know. You take what you've been given and you do know for sure, and then you use other context clues in the problems to figure this out. So, jumping back to the test. First, we're going to look for anything with similar units, like what that paragraph said. Here I have 9 gallons per minute and 12 gallons per minute. So I'm going to put 9 over 12, right? And these are gal per min. Great. Gallons per minute. Now I've written this as 9 over 12. No real reason. I just like looking at the proper fraction instead of the improper fraction. There we go. So 9 over 12. They're both gallons per minute. Great. So I know I'm going to be setting this equal to another fraction that is measured in hours. So let's think about this for a second. Where am I going to have to put my variable? Is that 2 hours going to go on top? Is the 2 hours going to go on bottom? Where is it going to go? I don't know. What I do know is that if the 2 is bigger than the answer I'm looking for, then it has to go on the bottom. If the 2 is smaller than the answer I'm looking for, then it has to go on the top, because of how I've set this up and because of the rules we are following that the book laid out. So let's figure this out. A pump that discharges 9 gallons per minute can fill a tank in 2 hours. Okay, so 9 gallons per minute, 2 hour fill. How long will it take to fill the same tank if you use a pump that fills at 12 gallons per minute? So we're filling the same tank at a faster rate, so it should take less time, which means the 2 hours is the longer time block. I'll put a T up here for time. We're going to solve for time. So rewriting this out a little bit more cleanly, we have 9 over 12 equals T over 2. Take the 2 over. I don't know what I just wrote there. And after following the same method outlined before, when we solve proportions, we end up getting T equals 1.5 in hours, and that's our answer, 1.5 hours, which is smaller than 2 as expected. Now, using the same method to set this up as before, I'm going to get 15 over x equals 12 over 60, or x over 15 equals 60 over 12. Doesn't really matter which way you did it. I set it up like the way on the left at first for myself. No matter what you end up doing though, when you solve it, you get x equals 75 psi. I realize now that I didn't read out the question like I normally do, so I'll do that now, I'm sorry. The hydrostatic pressure in a storage tank increases directly with depth if the pressure is 15 psi at the bottom of the tank at a depth of 12 feet. What is the pressure at the bottom of the tank if it is 60 feet high and completely filled? So again, this is a proportion problem. We set it up just like we would the previous one, using the same method as outlined in the book to set up our proportion, and then we solve it like we have in other proportion questions. Moving on to the last one. This one's a bit tougher. It is still a proportion problem, but we must do multiple proportions for this. So 4 industrial printers can print 18,000 pages in a 6-hour shift. A customer places an order for 45,000 pages, but only 3 printers are available. How many hours will it take the 3 printers to complete the order? So right off the bat, we are looking for the ratio of hours to printers or printers to hours. One or the other, doesn't really matter. Both will get us the answer. So we want to find the ratio of printers to hours. However, we don't have enough information to just solve that one directly just yet. So we must solve something we do know first. What we do know is that we know that 4 printers can print 18,000 pages in a 6-hour shift. So we can solve the ratio, set up a proportion and solve it for pages to hours. So I'm going to do that first. So pages to hours. I'm going to do this part in red so it stands out. And I'm going to set this up as 18,000 over 45,000 equals 6 over x. The reason I know to put the x in the bottom is because I know that the x is going to be larger. I know that it will take 3 printers, which is less than 4, longer to do the same amount of work. Except this time, we're doing even more work, so it's going to take even longer. So I know the x is going to be bigger. Reason I didn't bother putting the x in the top is because, well, for whatever reason, I like just putting the numbers that I see first in the question on top. So 18,000's on top. That's how I decided. So rearranging this, I get x equals 6 times 45,000 over 18,000. That's a bit better. X equals 15. This is hours. Great. Now, we're going to take this. We're going to say printers to hours. Now we're going to do the ratio of the number of printers to hours. So I'm going to start with 4 industrial printers over 3 industrial printers. And this is going to give me x over 15 hours. So how many hours will it take 3 printers to complete the order? Sweet. So let's go ahead and solve this now. So now I'm going to get x equals 4 over 3. Actually, I'll write this as 4 times 15 over 3 is how we'll write this instead. Punching this in the calculator, x equals 20 hours. And this is a very reasonable final answer compared to what was given in the beginning here. We have 1 less printer, and we have more than double the amount of work to do. So our time must be significantly longer. So 20 hours is much, much longer than 6. So this is done correctly. That was the final question. So if you have any questions about the test or how I marked it, whatever, either email me or ask me in class. All right.